Switches use trunk ports to simplify switch-to-switch and switch-to-router connections when VLANs are used. Recall that each VLAN constitutes a separate subnet, and that VLANs can be distributed among all the switches in the inner network. Without VLAN trunks, switches that are connected together would need one cable connection for each VLAN, as shown in the figure. Computer 3 and Computer 6 are in the same VLAN. If Computer 3 sends a frame to Computer 6, the frame travels to switch 1 and then to switch 2 via the cable connected to a port configured for VLAN 30 on each switch. Likewise, if Computer 1 and Computer 4 communicate, the frame travels from Computer 1 to switch 1 and then to switch 2 via the cable connected to a port configured for VLAN 10. Remember that a router is needed to communicate between VLANs since each VLAN is configured with a different network ID. So if Computer 1 wants to communicate with Computer 2, Computer 1 must send the frame to the router. The router then receives the frame on the port configured for VLAN 10 and sends it out on the port configured for VLAN 20. Again, one switch port and one router port for each VLAN is necessary. Using one cable connection for each VLAN obviously poses problems, especially as the number of VLANs, switches, and routers grows. Expensive switch and router ports are used up, and the amount of cabling required to make all the VLAN to VLAN connections would quickly get out of hand. This is where trunk ports come in. With trunk ports, a single cable is used to carry all VLAN traffic. When a switch receives a frame on a port configured for a particular VLAN, the switch adds a tag to the frame specifying the VLAN from which the frame originated. Let's look at an example. Suppose Computer 3 sends a frame to Computer 6, which are both in VLAN 30. When the frame reaches switch 1, a tag or VLAN ID is added to the frame and the frame is forwarded to switch 2 using the trunk port. Switch 2 receives the tagged frame, removes the tag, and forwards it on to Computer 6. Next, suppose Computer 1 sends a frame to Computer 5. Since they are in different VLANs, Computer 1 sends the frame to the router. When the frame reaches switch 1, it is tagged with VLAN 10 before it is forwarded to the router. The router determines that the destination computer is on VLAN 20. The router tags the frame and sends it out the trunk port to switch 1. Switch 1 forwards the tagged frame out its trunk port to switch 2. Switch 2 removes the tag and forwards the frame to Computer 5. As you can see, trunk ports are much more efficient than trying to use VLANs without them. The caveat is that you can only use switches and routers that support VLAN trunking.